Welcome to the lectures on problem solving and programming in C. This is lecture 20, and the title of the lecture is Recursion. Okay. Recursion is a concept involving modular programming where we call a procedure or function inside itself to solve computational problem. Recursive function is a function which calls itself. Okay. Let us see what are the advantages, what kind of solutions we can develop using recursion. This is a concept which may not be easy to understand for newcomers or beginners, but there will not be much stress on this course on this concept, but it is important to know that such a concept is there. Someone who is comfortable, they can learn and try to develop algorithms, procedures which are recursive in nature. So we will learn recursion using some examples. Yeah. What is recursion? Recursion. Recursion. Okay. Recursion is basically a procedure calling itself. Okay. A function calling itself. There should be a function call in a function call, function definition, there should be a call to itself. So what are the prerequisites, requirements of a recursive function? Requirements of a recursive function. Okay. We should define what is a base case. Define base case. Base case is basically a case where the problem size is small, which we can solve easily without going for the subproblem. Okay. Then define the subproblem. Okay. I mean, there should be a recursive call to subproblem. This is also known as call to subproblem. A problem. Call to same problem. Call to same procedure. Procedure with reduced input. Okay. So, I mean, a recursive procedure will have a call to itself with a smaller input. Okay. And then it should also have a base case where the problem is easy to solve. Let us try to develop algorithm for counting digits. Okay. How to count a digits using a recursive function. We have seen a iterative program, right? Counting a digits. So, for example, someone is given a number 1, 2, 3, 4, and so on, some 6. Okay. I don't know how many digits are there. Okay. But if someone gives me how many digits are there in the number excluding the least significant digit, someone gives me x. Suppose this number has x digits, how many numbers will have the original number, how many digits the original number will have? X plus. Okay. That is why this is called recursion. So what is the default value? Default value, suppose if the number is 0, the number of digits will be 0. Okay, let us write the procedure. Procedure, count digits, recursive. Okay, argument is int n. Sorry, n. N. What is the input? Input is a positive integer number. Integer number n. What is the output? It returns its number of digits. In n. Okay, that's a begin As I told you, the number should be, we should worry about what is the base case, right? What should be the base case? Base case is if the, suppose now n can be 0, okay? Or n can be single digit number. N can be single digit, okay? So see, single digit. So the easiest problem is if n equal to 0, number of digits is 0. If n equal to more than 1, single digits, number of digits is 1. So, we can take this as a base case. If n equal to 0, then return 0. Okay, right. Otherwise, end if. Okay. So let us count how many, what will be, how can I exclude the rightmost digit by, see, suppose if I pass n by 10, right? That is how this is this number. Let us say if I have number of digits t equal to count digits, I'm calling the same recursive function. It's recursive n by 10, n by 10. I'm passing the number excluding the rightmost digit. If this returns me d, what will be the number of digits in the original number? That will be return d plus 1. Okay, and so let us try to understand whether we have passed the requirement. If there should be a base case and there should be a call to the same procedure with the reduced input size. Okay, right. So this is called the base case. This is called the base case. Okay, and this is the recursive call to the same function, with reduced input. N was earlier n, now n by 10. It means that one digit is reduced every time. Eventually, you will reach the n. So how it works now? So let us say 1, 2, 3, 4 is the number. So what you will pass? The first recursive call will be 1, 2, 3. This next recursive call will be 1, 2. Next recursive call will be 1. Next recursive call will be 0. So from 0, you are returning 0. 0 and then you are returning will be plus 1. It will be written 0 here. Number of digits in 0 is 0. Number of 1 is 1. Number of 1, 2 is 1, 2, 2. Number of digits in 1, 2, 3 is 3. Number of digits in 1, 2, 3, 4 is 4. Like this, it will complete. Okay. So it is not that easy to understand, but you see here, you don't look at how things happen inside the program while executing the program. What happens? Don't worry about those details. Imagine that if someone can solve, say, smaller sub problem and gives you a solution, you think about how to use that solution to obtain your own solution. For example, if someone counts and gives me how many digits are there in the number, excluding the rightmost digit or the one digit, okay, then my solution will be x plus. So that's what I'm doing. I'm counting the number of digits in n by 10 and then returning the d plus. Okay. Let us try to develop an algorithm for this. Vi count digits dot c hash include tdio dot h int main. So I'm writing the main function then followed by c function. Int n printf enter a number. Input validation scanf %d %n if n less than or equal to 0. And if it is a negative number, then printf invalid. Then return 0. Otherwise, what we will do? Int d equal to count digits count digits recursive of n. Okay, printf the number of digits is equal to %d. Okay, now we need to define this function. We are following the top-down approach to problem solving. That is why I typed the main function first, followed by the actual function. So what will be the prototype of this function? Count digits recursive. It return value is integer. Count digits recursive. Then its data type is int n, right? Int n. The argument is int n. Okay. If n is equal to 0, then return 0. Otherwise int d equal to count digits recursive of n by 10. Okay, then return d plus 1. Right, and we need to define the prototype of the function here. Int count digits recursive of int. This is the prototype of the function. Okay, let us run this program. This is the count digits 1, 2, 3, 4, 5, 6. Number of digits is 6. Okay, minus 20, number invalid input, 0, 0 number is 0, 1, 2, 1, number of digits 3. So this is what we are solving the problem recursively. This is called recursive function because there is a base case when the problem is easy to solve, and then we have a there is a call to the same function with a smaller input value, subproblem with a smaller size, and then you are combining the solution of the subproblem to get the solution of the original problem. How do you get the solution of the original problem? If d is the solution of the subproblem, d plus 1 is the solution of the original problem. Okay, let us try to write another function which is counting the digits is over. Now printing the digits. Let us see how to print the digits. Printing digit procedure, printing digits. Procedure print digits. So first we will do for right to left. So it will be n. N is the argument. Input, output, begin. Input is a positive integer. Output is print digits of the number. Then begin. Okay. What is the base case? If n equal to 0, then return, just return, do nothing. Okay. Otherwise, d equal to n mod 10. Okay. Output d. Output d. Then we need to call the print digits. It's of n by 10. N. Okay. Now what happens is, suppose what is if I will suppose 1, 2, 3, 4 is there. Suppose for example 1, 2, 3, 4 is my number. What I will do is I will display 4, and then I will ask someone to display 1, 2, 3, 4. The subproblem will display the remaining thing. Okay. So there is no return value because inside the function we are supposed to only display. We are not returning anything. Okay. Right? Yeah. Let us try to develop this algorithm in C. I will copy this count digits function to display digits. Display digits. Okay. So, so display, I will call it as display. So what is the return type? So it display digits, display, undo, display digits of int. This is a prototype. So it doesn't return anything, right? So we should say void. Void is meaning for void is basically a function which doesn't return anything. Okay. When it doesn't return anything, we need to store it. We just need to call display digits. Okay. This is not needed. This is a function. Then this should be display digits. Void. Void. Display digits. If n equal to 0, return 0. Otherwise, I'm just translating this function. Okay, I'm just translating this function. Int d equal to n mod 10. Output is printf. 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 %d space d. Then there is a recursive call display digits of n by 10. Then return. So here also it should be written only because we are not written. Since the function is void, we just need to return the control. It doesn't return any value. We just specify only return. It means that void return. It doesn't return any value. Only the control return to the call. Let us run this problem. GCC display digits 1, 2, 3, 4, 5. So see the digits are displayed right to left. Okay. Now let us try to understand. Let us try to move this print statement after the if after the recursive function. Let us see what happens. Okay. Earlier, this print statement was before the recursive statement, recursive call, this call. Now I made it after the recursive. Let us see what happens. You see here what happened? Without any difficulty, we are able to, without any computation, power computations and all, we are able to display the number from left to right. Left to right. Okay. Earlier, you remember how you solved the displayed the number from left to right? We had to compute number of digits, and then we have to compute 10 to the d minus 1, then start extracting the digits one by one. That was a difficult job, right? Now in this, we are able to do, without that, we are able to do. Now, what happens, what this recursive call is, if someone displays all the digits from left to right except the last digit, what will be my duty? I just need to display the last digit. So this recursive call will display all the digits before the rightmost digit, least significant digits. And then I'm displaying the last digit, rightmost digit. That is the numbers are coming from left to right. Whereas if I move this print statement before the display, what is happening? I am first displaying the rightmost digit and then followed by asking someone to display the remaining digits. That is why digits are coming right to left. So that is so this is the advantage of recursive function. We can solve computational problems very easily using recursion, which are otherwise difficult to solve using a iterative functions. Okay, this is just an example, right? So we have seen how to display the numbers from right to left or left to right. So especially displaying numbers from left to right is difficult. Difficult in the sense we have to do a lot of computations that we can avoid using recursive functions. So for many computational problems, recursive functions will give a easy solutions. So our solutions that are easy to understand and understand. Okay, right. I will stop here. Thank you. We'll continue the discussion on the course in the next lecture. Thank you.